Okay, so today's discussion is on box fill calculations. And the primary reason for box fill calculations is to allow for dissipation of heat and to protect the conductors and the devices in the box. Also to make the installation and demolition of the boxes easier. The primary table that we use is 31416A, which shows different types of metal boxes: round, square, device boxes, otherwise known as handy boxes, and it gives their dimensions and how many of the types of conductors, the sizes of conductors, can fit in those boxes. Each box is also calculated with the volume that each box has, multiplying the length of the box, width of the box, and the height of the box. Okay, so basically what you're determining is how much space is being occupied by conductors and devices in the box, and you're comparing that to how much space is available. If the items in the box exceed the space available, you are outside of code and you must choose a larger box. Each of the conductors and each of the conductors and items in the box have certain rules that are counted to calculate the total volume that's being occupied. So we will go over those in this demonstration here. But primarily, it's this table right here, 314.16, and this table, 314.16b. So to get you familiar with the tables and how to use them, we've got about 8 examples here that we could go through. First example is, what is the volume of a 4 by 1 1/4 inch square box? You find the square boxes, you go to 4 by 1 1/4, and you see that it occupies 18 cubic inches. What is the volume of 4 by 2 1/8 by 1 7/8 device box? You find that in the device boxes here. 4 by 2 1/8 is here by 1 7/8, and you find it occupies 13, or is available 13 cubic inches. How many number 18 conductors can be installed in a device box that is 3 by 2 by 1 1/2? You find 3 by 2 by 1 1/2, and you find 18, size number 18 conductors, and you see that 5 size 18 conductors can fit in that box. How many number 12 conductors can be installed in a square box that is 4 by 1 1/2? You find that square box, 4 by 1 1/2, and you're determining how many number 12 conductors can fit in it. You go to the column 12, and you find that 9 could fit in it. What is the minimum size square box that is needed for 2 number 12s and 4 number 14s? Well, in this table, it gives you the conductor allowances for the particular size conductor. This is only done for determining box fill, and this is the table that is used. So number 12 occupies 2 1/4 cubic inches. Multiply that by the quantity in the box, and you do the same for 14. They occupy 2 times there are 4 of them, and you make the calculations, you add them up, and you find that they're occupying 12 1/2 cubic inches. And the next point is to find the minimum size square box, and we find that it is a 4 by 1 1/4 square box with 18 cubic inches, and that's sufficient for those conductors. And you find that you do the same on example 6 here. You have 3 number 10s, 2 number 8s. You get their volume amounts by this table. You make the calculation and you add and you find the minimum size device box that can accommodate 13.5 cubic inches of conductors. And we find that a 3 by 2 by 2 by 2 3/4 device box, which is 14 cubic inches, can accommodate these conductors. That's the device box there. Example number 7. What is the minimum size square box needed to contain one receptacle, 2 number 12 conductors attached to the receptacle, and 2 number 14 equipment grounding conductors? So you must refer to the article 314.16b 4, and you will find that any receptacle or devices get a double volume amount based on the largest conductor connected to it. Largest conductor connected to it in this case is a number 12 that is gets a volume allowance of 2 1/4 times the double volume allowance, you get 4 1/2, and there are 2 number 12 conductors. You make that calculation. 1 number 14 EGC gets the size of the largest EGC in the box, which is a number 14. That gets a count of times 1, which is 2. And when you add them up, you get 11 cubic inches. Then you find the minimum size box needed. Minimum size box, the minimum square box needed is a 4 1/4. 4 times 1 1/4 square box, which is 18. You need 11. The box is 18. And that gives you plenty of space, which is right here, for your conductors. The last example, what is the minimum size square box that will contain 2 internal clamps, 1 hickey, 2 equipment grounding conductors, and 2 receptacles with 4 number 12 wires attached to the receptacles? You go to this article, 314.16b2. You find that clamps, any number of clamps, gets a volume allowance based on the largest conductor in the box. You only get 1 allowance for any amount of clamps, so you make that calculation, 2 times, or 2 1/4 times 1. A hickey is the same thing. It's a fixture hickey. Any amount of hickeys will get 1 volume allowance based on the largest conductor connected or contained in the box. That's a number 12. 2 1/4 again. EGCs only get 1 count. Doesn't matter how many there are. They get 1 count based on the largest EGC in the box, which is number 12. And then the 2 receptacles get a double of volume allowance each based on their largest conductor connected to them. And the 4 number 12s get 2.25. You make that calculation, you add them up, and you find that you have 24 3/4 cubic inches that you must accommodate for, that you must have for your box. You're looking for the minimum size square box, which is the 4 by 11/16, which is a 5S box basically, by 1 1/4 square box, and that gives you 25 1/2. You have enough space for them in that box, which is right here. There's 25.5, and your items in the box add to 24 3/4. You got it made. You can continue to move on with your calculation and have enough space for your items in the box. So that's box fill calculations. I hope that makes sense. You could review and back up on the tape any amount of times that you want. And we'll be talking more about this in the next lectures.